Our next unit is about right triangles, but as you see, the title is Radicals and Right Triangles. In order to talk about right triangles, we need to talk about radicals a little bit. Jumping ahead here, right triangles, well, we've talked about them a little bit, specifically with the Pythagorean theorem, and what we're going to do is more with the Pythagorean theorem, but as I said, radicals is going to come up in this. Now when we say radicals, it means square roots, cubed roots, etc. We are only going to be working with square roots. So even though I say radicals, we're going to be targeting specifically square roots. You're going to learn a lot more about radicals next year. Let's look at the rest of our schedule. One thing that mine says that yours doesn't is the fact that you need to be bringing your own Inspire every day. And it specifically needs to be the Inspire because the other calculators are not going to do that for you. It looks like at first we're going to work with square roots, as I said. Then you see we jump to the Pythagorean theorem, and you're going to see this deals more with the Pythagorean theorem. Like I said, we're going to see some new aspects of it. And then eventually, this is all basically some review stuff, and we'll be taking our Chapter 8 test. At this time, I recommend that for your class, you go through your schedule. You know what today is. You see that our second day is going to be on Monday, but you mark what days of the week this will work for your particular period. So right now I would pause this, write in the dates, and then start this up again. Well, let's go to our first page of notes. We're going to be looking at square roots today. We're going to look at both approximating and finding the actual answer. And if you notice, all of these questions are the same questions as these are. That is on purpose. Let's think about what we do know about convenient square roots. So for instance, square root of 12, that's not very convenient. But let's see, the square root of 9, that's convenient, and the square root of 16 is convenient. The reason I'm picking those two convenient ones is because the numbers 9 and 16 are around the number 12 that I'm trying to aim at. 9 has a convenient square root, specifically 3. 16 has a convenient square root, specifically 4. So root 12 must be somewhere in between there. Let's see, 9 to 12, 12 to 16. It's almost in the middle. Not quite. I'm going to guess that it's 3.4. We'll see what the real answer is later. But that's going to be my guess for this one, 3.4. Let me do something similar with the square root of 18. Let's see, square root of 18, some convenient roots. Let's see, the square root of 9, but square root of 16 was better. That's even closer to 18, so I'm going to use that. Can you think of one that would be on the other side of 18 that's a good square root? Did you think about 25? I like these numbers because they have convenient roots, and 16 and 25 surround what I'm targeting, which means 4 and 5 must surround the decimal that I'm targeting. 18 seems a little closer to 16 than 25, so I'm going to guess something closer to 4 than to 5. Let's say 4.2. And maybe you thought of something different that was near 4.2, and that's a perfectly good guess. What I want you to do right now is take a guess on what the answer to number 3 might be. And then if you haven't already done so, get out your calculator. So pause this now and do those two things. Answer 3 and get out your calculator. So let's see what the calculator is going to say the square root of 50 is, as well as the square root of 12 and square root of 18. I'm going to actually start with the square root of 12. If you're confused on what buttons to push, you'll see them turn red on my calculator. I want the square root, so I'm going to hit Control X squared. And if I just type in the numbers 12 and hit enter, it gives me, oh, not a decimal. Well, let me make it give me a decimal to see if my decimal was a good guess. I'm going to say square root of 12, and then I'm going to hit Control Enter. So it's got two numbers here for the square root of 12. And if you notice 3.46, well, we had guessed 3.4. Maybe I should have guessed 3.5, but I think 3.46 is a pretty good guess. 3.4, sorry, is a pretty good guess. But it's telling me that the answer was 2 root 3. That is actually going to end up over on this side. The real answer is 2 root 3. And you might think, no, the real answer is right there. It's 3.461. Well, that's actually not the real answer. Even this isn't the real answer. It goes on and on. And so when we talk about the real answer, we mean with no approximating. Next year, you're going to talk about how to get these quite a bit. Today, I'm going to slightly talk about it. You'll talk about it a lot next year. This year, we're going to focus on two things. Can you make an approximation without using a calculator? And can you get this version of the answer with your calculator? And again, the Inspire is going to be the only one that will show you this version of the answer. So you need your Inspire every day. Bring that to class. Don't rely on us to have it for you. Let's see how your guess of square root of 50 was. Square root of 50. Oh, wait. That's the real answer. Okay, so I'm going to put that on my paper in just a minute. If I do Control Enter, did you guess something near 7? Maybe 7.1 is something you guessed? While I'm at it, let's put down that the real answer to the square root of 50 is 5 root 2. We'll talk about ones like number 4 in a little bit when we're looking at problems down here. But before we get to those, I want you first to write down 3 convenient radicals, or in other words, 3 convenient square roots that we're going to be working with this chapter. And then also write down what their answers are going to be. All right, so pause this and start it up again after you write your answers. These are the ones that I wrote. Did you write something similar to this? Or maybe you wrote some different ones, and you can see if you are correct by checking them on your calculator. What I want to do now, though, is talk about how I would simplify something like this by hand rather than using my calculator. And again, it's going to be very brief to kind of remind you about some stuff that you may have seen before. Square root of 18. Before, above, I was interested in trying to figure out numbers that this was close to, so I had 16 and 25 and roots because those were good roots. That's not what we're talking about now. Now we're talking about how to get this answer from up above. So one that the calculator will tell us. Actually, before I start that, let me just even see what the calculator is going to say the answer is. The calculator tells me that the square root of 18 is 3 root 2. And let's talk about how we can get 3 root 2 by hand. So again, I know the answer is going to be 3 root 2, but how can I get that by hand? The key is going to be right here. To simplify a square root, you take out perfect square roots, which is also groups of, well, it's an amount. Groups of 2 is what we're going to be taking out. So what I mean by that is I can use my old factor tree. This is 9 times 2. This is 3 times 3. This is a real quick reminder. Here are my groups of 2. I have 2 3s. That means one perfect 3 is going to come out. And I'm going to have a 3 in my answer. And unfortunately, there's this 2 right here that's left over. That is going to end up staying inside the root. There's my 3 root 2. All right, let me show you another way that you can complete this problem besides using the calculator. It would be to take out, instead of groups of 2, to take out what this means, the perfect square root part that we're talking about. Take out perfect square roots. Well, in this problem, 18 is the same as 9 times 2. So the square root of 18 is the same as the square root of 9 times the square root of 2. I like this one. It's the perfect number 3. But I don't like this one. it doesn't have a perfect number, so that means it's just going to end up staying in the root, and that's how I'm going to get 3 root 2. Let's try another one here. I'm going to take the perfect square root approach again on problem number 7. 8 is the same as 4 times 2, so the square root of 8 is the same as the square root of 4 times the square root of 2. This is the perfect number 2, and this, unfortunately, doesn't change, so the answer would be 2 root 2. And you can look at your calculator and check that. Let's look at problem number 8. This one seems a little different. It's got this multiple up in front. I don't need to worry about that. I'm just going to take it with the problem. I have a regular 2. And then I'm trying to think of what good root numbers go in 75. Let's think about some money here. Isn't 75 cents 3/4? Or 3 and 25? But those are in roots. I personally do not like to write it the order that you see this in right now. I prefer to see it in the good root first. That's this one. And then the one that's not going to work out so nicely second. So instead of writing root 3 and then root 25, I am going to write root 25 and then root 3. I'll show you why in the next step. This turns into a good number, 5. Wait, I don't want to lose this down here. Well, what do you think is going on between these two? Is it 2 plus 5 minus 5 times 5 divided by 5? What is it? Well, up here, there is no symbol necessary in between it because it's invisible for multiplication. So it's going to be 2 times 5, or the regular number 10. But I can't lose the fact that I had this root 3 sitting over here, so I tack that onto the answer. 10 root 3 is my answer to this. And again, you can check that on your calculator. Will you try problems 9 and 10, and then start it up again and see if you're right? I hope you liked number 9. That one was quick, one that I hope that you just know. But maybe 10 felt a little more difficult. I am having a hard time coming up with two numbers that multiply to 140 where one of them is a good number. They have to multiply together. So for instance, 14 times 10 is 140, but neither of those are good square roots. But I'm having a hard time finding good square roots. So instead, I'm going to go back to our takeout groups of 2 method. So I'll keep going with this. I split it into 14 and 10. Well, why don't I keep going and split that into, well, let's see, this is 7 and 2. This is 2 and 5. Looks like my old factor tree, and I'm done factoring. We said groups of 2 would be good. Here's my groups of 2. The square root of 2 times the square root of 2 is the square root of 4, but I'm going to write the square root of 4 as the regular number 2. Then I have the square root of 7 and the square root of 5 left, and the square root of 7 times 5 is the square root of 35. This is going to be my answer, and I can check that on my calculator. As I said, you're going to get a lot more explanation on simplifying radicals by hand next year. This was just a short reminder, or for some of you, a short introduction of how it works. But our main focus is actually going to be on the calculator. And I want you to go to the next page, and I want you to see if you can make your calculator tell you the answers to all of these. And when you're ready, start it back up again. Here are the answers that I got starting with number 12. I'll make it so you can see the last two as well. And again, we're getting the real answers, not the close answers. And that's what we're going to be looking for in this chapter, are the real answers. If you have all the notes down correctly, then go ask for the next part. Good luck!